In the previous video, we noted that a point in the polar coordinate system can be represented multiple different ways, whereas a point in the rectangular system can be only represented one way. In this video, we'll focus on how to represent those points multiple different ways in the polar system. We'll start by focusing on 4 2-pi thirds. And I'm going to back up to the previous graph to give you a visual. I realize that if you're taking the notes, you've already filled this graph out. You don't have to erase anything, just follow along for now. Again, we're looking at 4 2-pi thirds. To plot that point, we again, starting on the polar axis, sweep out an angle to 2-pi thirds. So here's 2-pi thirds. So we're sweeping that angle out to 2-pi thirds. And we want R to be 4. So from the pole, 1, 2, 3, 4 units away, we have our point 4 2-pi thirds. One alternate way to represent that exact same point would be to change the angle. So starting again at the polar axis, we could rotate around one full revolution and then come back to the same angle. Here, we still have R at 4, but the angle, we made one full revolution, 2 pi, plus 2 pi thirds. So that would be 4, 2 pi we can represent as 6 pi thirds. Then we have plus 2 pi thirds. That will give us 4, 8 pi thirds. That is one alternate way to represent that exact same point. And we could, instead of rotating around once, we could rotate around 2 times and then back to 2 pi thirds. And again and again and again. We could rotate around that as many times as we want. So there's one way to represent it. An alternate way to represent that exact same point is to, starting from the polar axis, what if we swept the angle out in the opposite direction? Down here. So here's our terminal side, but this time we want to be on the opposite side of our terminal side. So we want our point to be up here at the same place. That is a negative R. So negative 4, and the angle in this case is negative pi thirds. So again, we're representing the exact same point a different way. We have 3 different ways to represent that exact same point. And again, there's actually an infinite number of ways to do that. We just change the angle. Or in this case, we change the angle and R. So in summary, if we wanted to rewrite the coordinate r theta a different way, one way to do it would be to keep r the same and add cycles of 2 pi to your angle. So again, that is, we keep r the same and add cycles of 2 pi. We could add 2 pi, 4 pi, 6 pi, or we could, k could be negative, so we could actually subtract 2 pi, 4 pi, 6 pi, and so on. An alternate way to rewrite that would be to change r, make r negative. So we change r and start by adding pi and then multiples or cycles of 2 pi. So in order to change r and make it negative, we would then add pi and then cycles of 2 pi. That is 2 pi, 4 pi, 6 pi, or negative 2 pi, negative 4 pi, and so on. Let's look at an example. If we're starting with 2 pi fourths, one way to do it would be to keep r the same. So let's keep r the same at 2, and we want to change pi fourths. Notice we need to add a cycle of 2 pi, or a multiple of 2 pi. So we have pi fourths plus, let's just say we add 2 pi. That would then give us 2 comma, we'll need to get an equivalent denominator. So think of 2 pi as 8 pi fourths. That will then give us 2 comma 9 pi fourths. So this point is the exact same point as the point we started with, 2 pi fourths. An alternate way to do this, using our second method, is making r negative. If we change 2 to negative 2, we would then have to add pi to pi fourths. We could also add an additional 2 pi or 4 pi or so on, but for now let's stick with just pi. Again, we'll need to get an equivalent denominator. So pi fourths plus 4 pi fourths. This is negative 2, comma, 5 pi fourths. So we have, yet again, an alternate way to write that exact same point. In our next example, negative 2, 7 pi 6, we want to write it an alternate way. Again, let's use method 1. Let's keep r the same. Keep r as negative 2. If we do that, we need to change the angle. We can add multiples of 2 pi. We could add 2 pi again, like we did here, or we could subtract 2 pi if we wanted. Let's subtract this time. We have negative 2, and again, we'll need to get an equivalent denominator. So let's do 6, so that will be negative 12 pi over 6. This gives us negative 2, comma, negative 5 pi 6. Again, this is the same point, just written a slightly different way. Second method is what if we wanted to change r, change the sign of r. So r is now positive. Starting with 7 pi 6, we then need to add, or we could subtract pi. Let's subtract pi this time. We have 2, and again we'll need to get equivalent denominators. So let's think of that second part as 6 pi over 6. We now have 2, comma, pi sixths. And again, this represents the exact same point. I encourage you to graph these. Graph these 3 points and recognize that these are the exact same point. And same thing over here. On your own, graph these 3 points and recognize that they are the exact same point, just different ways to represent them.